Hello everyone, I hope you're having a good day. Today we're going to be speaking about intensely pleasurable responses to music coupled with activity and brain regions implicated in reward and emotions. This is Isaldin Swelim. This is directed to Professor Bengi Yannick Ilhan on June 1st, 2021. Let's dive into it. Introduction. In this study, you will see using positron emissions tomography, a true demonstrative study of the neural mechanics and the neuropsychological effects in the brain, structural parts that happens in association with music, when in real-time events it do associate with feelings like reward, motivation, happiness, food, sex, drugs, and all sorts of euphoria-inducing responses. Also, with physiological changes and responses in the brain cortex with demonstrate specific different behaviors, for instance, change in heart rate, blood flow, electromyogram. All of these findings that put music in association with biological as general and as physiological in-depth relevant stimulations via close cerebral neurocircuit movement. In the upcoming slides, you will start seeing a lot of codes and shortcuts for a longer versions of the names. I will explain each of them along the way. First, this trial that you are seeing in front of you, this experiment, has been done on multiple subjects using something called controlled music conditions. It was used to stimulate and provoke a specific emotions related to what we discussed lately, but it was mainly named something called chills. That's basically the emotions reacted to it. Despite or instead of mentioning each and every emotion with its own specific numbers and reactions, we could just call them chills for easier conditioning and for easier specifications. So this was exactly an average measurements of the left, or the, for other example, of the HR. HR is what we call the heart rate at beats at minute, and then EMG, and respiratory relative depth for subject selected. Respiratory system, it is the system that helps us breathe, that is containing from multiple organs, from lungs to brain to throat, multiple systems. For subject selected, chills and control music conditions with corresponding examples of individual measurements, center and right. For each condition over the time course of selected scanned 90 seconds for each and specific subject. Error bars here, as you can see, indicates that for each average, the same subject scan is shown for individual measurements of heart rate, of the EEG subject, that's subject 1. A different subject, that's subject 2 for example, is shown for respiratory. Note that subject 1, control music, was subject 2, selected music. Black bars on the abscissa of graphs in the center column indicates time periods corresponding to chills. Chills in all three examples, the chills rating was 7 on a scale of 0 to 10. These kind of experiments determines to understand the music effect of the emotions when it provoke a specific emotions, when it have a normal effect, but in this type of an experiment it's not actually provoked by a normal event, it's provoked by the usage of music. Each subject, now we explain it. Each subject selected music that was used as another subject's emotionally natural control that does provoke a specific emotions, such that the group average data analysis involved a comparison of identical sets of stimuli, the stimulations that we just talked about. For example, if a stimulus that's related to project A evoked chills in subject 1 and stimulus B evoked chills in subject 2, then stimulus B might serve as control music for subject 2. and stimulus A might serve as control music for subject 2. Each music stimulus was used only once as control. Subjects were asked to rate the emotional intensity of how they feel and also of their responses to each of the other 9 music selections to qualify as a natural control, or whether it's a natural control or emotional intensity rating. Both of them were actually required to be on 3 on a scale of 1, 0 to 10. 10, 5, 10 or 5 as most intense. Subjects were familiarized with their control music before scanning to minimize responses attributed effects of novelty. Here, as you can see, this is a regression correlating the RCPF. The RCPF is the regional cerebral blood flow that goes through the brain, and it has multiple other functions with ratings of its chill intensity, because the emotions requires the brain or forces the brain to provoke in a specific physiological manner, not just neurological, not just psychological, but actually a physiological manner, which puts everything in one course. So it actually provoked the blood flow to be going in a specific way. So the chills of intensity here, the corresponding of the L venture, that is the parts of the regions of the brain that actually provoked a specific correlations, which we call some of them as positive, which we can consider some of them as negative. Of course, I'm not a medicine expert to determine exactly the numbers and the exact effect, but we would see more explanations of it in the next slide. The analysis of this data. This data analysis calculated to assess the significance of the relationship between chills intensity rating and the CBF. The CBF is again the cerebral blood flow without the R, without the region. Their linear regressions. The data set for this analysis consisted of normalized CBF values obtained in each subject during each of the subjects selected and control music scans, yielding a total of 60 image volumes. Chills intensity ratings were set all to 0 for all control scans, so you can go on with a deeper understanding. The effect of the variation in chills responses was assessed by means of analysis of covariance, with subjects as a main effect and the chills intensity rating as a covariate. The following model is the normalized cerebral blood flow of subject 1 on the scan. The subject effect is removed, and the parameter of interest is the slope of the BP. The BB here, as we can call it, is a shortcut for blood pressure, of the effects of the chills rating on the cerebral blood flow. The subject effects regressor was subtracted from the analysis to remove the influence of the individual differences in responses that would have been implicitly removed in comparison of means, model, task baseline, which is 0. Removable of this effect allowed grouping of within and between subject data in the regression analysis value equal to or exceeding. A value equal to or exceeding a criterion of t equal 3.53, as we saw here before the t sections, that it was multiple values that was already exceeded the 3.5, and there was other values that was not exceeding 3.5, either whether it's equal to their 3.5 or less. But the significant that was considered 3.5 was considered significant, two-tailed, the P and the 0.01, the pressure, the two-tailed. Two-tailed here means indefinitive, yielding a false positive rate of 0.58 in 182 resolutions elements, each of which has dimensions 14 multiplied by 14 multiplied by 14 millimeter. That's kind of how you can actually identify or measure the space, or let's say the distance. If the volume of the brain gray matter is 500 centimeter cubic 24, medical infos of the brain structure to control within subject differences in familiarity that may have existed between the subject selected and control music conditions. The regression with chills intensity was recalculated to include scans from only 2 subject selected music conditions, because specific regions were hypothesized shall we say, to be active in this analysis. The significance actually was less. In addition, the regional cerebral blood flow values from left ventral striatum, part in the brain, left dorsal midbrain, left hippocampus, amygdala, right amygdala, and VMFV. The VMFV, if you are wondering what it is, it's the ventromedial prefrontal cortex. This is a part of the prefrontal cortex as general in the mammalian brain. You can say it's a smaller part of the brain, but it's actually considered to be control of a lot of things. So, were extracted from individual scans, subjects selected music conditions only, not all the subjects that were used for a selected music trials, plotted against the subject rating of chill's intensity at the figure 1 that we saw at the beginning. A Pearson correlation was used to determine the correlation coefficients for each of these regions. For these regions, plots and correlation only RCPF values were extracted before normalization. To correct for this, both regional cerebral blood flows values and chill's intensity rating were normalized to the lowest value for each subject, such that the lower values were set to 0. And mainly, you can really read all of this and analyze it by yourselves. I don't have to read all of this, but it only comes to one understanding. These parts of the brain that you are seeing in front of you, that here the minimural plane at these parts. Also, you can understand here that the VMPF, the effect that it has actually in one of the therapies, and then it goes on again, and the other effects that it does have related to this specific chills, where it gets actually so much at this point. You can really see the parts of the brain that is glowing, and the more pressure of the glowing, the more you can see the glowing instead. And all of these codes that you can see in front of you, it's actually a code for the parts of the brain, when it comes to the side, when it comes to the back, when it comes to things, the parts that you can understand it through a scan. You understand me at this point, I suppose. The OF, the HAM here specifically, this is a specific part in the minimal brain that correlate the responses of blood flow related to neurological support. Shall we give it in a better understanding? The conclusion of this is the conclusion of this, which if you read it more again, you would really understand this even more. The music can affect the brain in more ways than we can imagine, in which it can cause changes in moods, whether to increase it or decrease it, and in such a way it can cause the neurophysiological functions of the nervous system and the cerebral parts of the brain to acknowledge them, not just understand them, but acknowledging is totally different, which accordingly affects the brain neurological and physiological behaviors, how he responds. That's why I said acknowledge, not understand, which lead the brain to think or to act in a certain way and to behave in another, and to give orders partially in an unconscious way to certain parts of its power to behave in a certain way. I know I use certain way in multiple times, but it's because it's a specific reactions with a specific conclusions. A certain way to achieve a desired intent or action, in which the main drive is not the music, but it's the waves playing the biggest role on how these emotions emerge and reshape, and how our beautiful brain and its magnificent components act without us breaking a sweat over it. Literally, the brain just does everything, and even sometimes the brain doesn't know actually what is he doing. Either we are speaking about the brain as a whole, or are we speaking about its own reflections or its own reactions, whether it's neurological, physiological, psychological. We are all speaking about a specific reaction that happens through the brain that actually forces us or translates to us as a specific understandings. These kind of things that the brain actually doesn't really have a full understanding over it, but it does acknowledge it and it does react to it, and it's translated to our body through a specific orders, through if it's a specific hormones or a specific physiological responses. But for us, we translate it as emotions. Thank you very much. I hope you understand it, and I hope you dive deeper and deeper into this subject. Thank you.